Hello, my name is Alvin, we are the Yang Gang, and this is our Kabuto Bot. Regarding design, our quadruped robot is modeled after Kabuto. Kabuto is a horseshoe crab creature from the popular Nintendo franchise Pokemon. Now, if you're wondering why the shell of the robot looks different from the source material, we decided to model what is known as the shiny form of this Pokemon, just to add some visual flair. Our purpose for building this robot was to construct an interactive toy with which a child can play. We felt modeling a Pokemon was a good idea in this respect, considering the franchise appeals significantly to children, though it is loved by all ages. Before coming in contact with the user, our robot stands from its collapsed position and cycles through multiple idle stances. These idle stances consist mainly of leaning left and right. Eventually, the robot ends standing in place, and when it senses an approaching user, it begins to shriek and flee playfully backwards. After fleeing backwards for a little while, the robot pauses, sits on its hind legs, and sings the Pokemon theme song.
Hi, so I'm Dominic. I'm here to explain the engineering design behind it, our wonderful little Kabuto and his little shell on top. So first and foremost, we have the body of Kabuto, which is made out of different bracket pieces and also out of plate pieces. The legs are designed as closely as I could possibly get it to the MIT cheetah, which we took inspiration from for like the leg and locomotion. And also, the body is a lot more lightweight than its original design, and we had these pieces 3D printed so that it could have a running bar that went all the way across. That's pretty much it. Thank you.
Our robot uses 8 finite rotation servos to control the motion of its legs. With our design of the legs as a 5-bar linkage mechanism, we attach 2 servos to each leg, one at the front and one at the back. When the robot drops down, it lifts its legs up into its body by writing opposite angles to the servos on each leg. For example, for the two left legs, the front servos go to 0 degrees and the back servos go to 155 degrees, while the opposite happens on the right legs due to the orientation of the servos. Our motors go to 155 degrees rather than 180 because they are limited in their range of motion, which we discovered through testing and calibration. For the standing motion, the servos perform the exact opposite motion of the dropping down function, with reverse degree measures and a slight delay in between the movement of the front and back servos to allow for enough time for the servos to complete their motion. The robot moves backwards through the repetitive motion of the servos swinging from 155 to 0 degrees, or vice versa. The front left leg and the back right leg move first, followed by the front right leg and the back left leg. This allows the robot to simulate a walking motion, and the small bars attached to the base of its legs act as feet to help push itself backwards, away from the user.
Since Kabuto required 8 servos to move, we used a PCA 9865 servo controller. This servo controller has the ability to control 16 servos, allowing for greater precision over the position of each servo. Moreover, due to the current requirement of the servos, we needed an external power source to power them rather than relying on the Arduino's 5-volt pin. After experimenting with different batteries, we found that the Amazon Basics 9-volt battery was optimal for our time constraint. However, given that the servos have a maximum operating voltage of around 6 volts, we also used a voltage regulator that reduced the battery's 9 volts to 5 volts. And we also used another 9-volt battery to power the Arduino. We thought implementing a buzzer would appear as though the robot would have emotions. We programmed the buzzer to have an alarming sound whenever the sensor sensed an object within 8 centimeters. Also, when the robot is propped up on its front legs, it plays the Pokemon theme song to express a happy emotion. And finally, we used a slide switch to give the user the ability to turn the robot on and off.